Message. You message home. Sit up, sit up.
So only you have to do showing like the steps and maths.
Where's this room? Here. Check where you go. Come along. What if you knew? You knew that it was so what is the technical like? 4 will give the 6 and from 6 onwards, 2 hours. Thank you. Just is coming. Any idea? What you have seen last time? So that's it. Okay, we have already started with gravitation. We already started. So I'll just give you a brief about what we have already done and then you can pick it up from there. So you found it interesting last time you were to talk about? No. Which day? Because we will take a later read. So we were talking about gravitation. One thing that we already know is that we drop any body, it will fall to the surface of the earth. Okay? And we also notice another very important thing, that it always falls in a straight line. Obviously, because we are talking about anything falling on the surface of the earth, obviously it is falling towards the center of the earth. So what is it that is actually dragging all these bodies towards the center? And we have realized that it is nothing but gravitational force. So it is the force that is pulling all the things towards its center, and this basically is what is known as a gravitational force. Okay? So we have already seen in the previous lesson that force can bring about a change in the motion of a body. Okay, so what is going to happen to this body which is being dropped from high? Will it move at the same velocity when it is falling towards the surface of the earth? Will it have the same velocity? It will have acceleration. It will have acceleration. Will the speed increase? Yes. Right? Because as it is coming closer and closer towards the surface of the earth, obviously the force which is pulling it is also more, right? Because the distance is decreasing, isn't it? Because the object is at a very high, elevation or whatever it is, altitude. Suppose you are dropping it, what is happening? You can see that the distance is decreasing. So as the distance is decreasing, obviously the it is activate more amount of force. So last time we have seen that for us to understand something about the gravitational force, this is depending not only upon the masses of the two bodies. So suppose you are having two bodies. You are having a body with having a mass, 1, and let us say there is another body having a mass 2. Correct? So it depends upon the masses of the two bodies. So we said that F is directly proportional to the mass of the two bodies. Okay? And we are also seeing that it depends upon the distance between the two bodies. So the distance is from the center of the two bodies. And if I write that distance is d, don't get confused, distance is d, then you think the force is directly proportional to the distance or inversely proportional to the distance? Inversely. Because as the distance is increasing, the force is decreasing. नहीं आ रही, ठीक है. So it is found that it is inversely proportional to the distance. Not only to the distance, but it is also inversely proportional to the square of the distance. Did you understand? Suppose this is 5 meters. So we have to put it as 5 square. Did you understand? Now we have got two equations. So equation number 1 and we have got equation 2. Obviously we are going to combine 1 and 2. So we get it as force is directly proportional to F1 and F2. This is on the numerator. And in the denominator we have got a d square. So it is equal to this part. Is that okay? But we still do not have an equation. It is only showing you the time. It is proportional. So what do we do? Finally we write it as F is equal to capital G, which is going to be a constant, M1, M2, which is the masses of the two bodies, and D is the distance upon D square. Okay. And what is this capital G? This capital G is what is known as a gravitational constant. So this is gravitational constant. Why do we call it as constant? Obviously, this number will not change whether you change the mass or whether you're changing the distance. This G is always a constant. Whether you're talking about the bodies which are present on the earth, or you're talking about the body which is present somewhere in space and gravitational effect which is felt on the surface of the earth, this value of G is going to be a constant. Is that okay? So just take down a few lines from here, and from here we'll pick it up. Come on, write down in your notebook. Have you written anything last time? No, no. Except for the diagram, I think.
Yeah.
Only the diagram we have written. Have you written the law? Have you written the law? Every object in the universe? No, you have not got. Okay, come on. Now today's this thing. State universal law of gravitation. State universal law of gravitation. Now here we have, look at me. It's two legs, two statements. Come on, write up. Every object in the universe attracts every other object with a force which is proportional to. Switch off the AC, it's making so much noise. Park that side, I think. This is the side, I don't know. Just switch on. Yeah, this one, yeah. Look at this one, yeah. This is right now, right now. You can switch this on, then it's not making much noise. That's better. So much better. So, which is proportional to the product of the masses and inversely proportional to
Proportional to the
masses and you don't have a textbook.
because I thought today is math. 2 rounds. Math one.
Check your timetable.
2 in the morning I checked it over to it because 6 4 8 maths, but I was showing math and 4 physics.
I checked it in the morning, it was there for my timetable. Yeah, it was there. Okay, and inversely proportional to the square of the distance between them. Okay, so we have also drawn something here. What does this light tell us? Shows us the direction of the force. So how is the force acting? Force is acting along the line which is joining the centers of the two bodies. Okay, so there's also another sentence there. See in your textbook. The force is, okay, it's not a part of the statement, but just put it in bracket for you to remember. The force is along the line joining the centers of the two objects. Okay. So what I have given you now is a mathematical expression of the same gravitational law. Is that correct? Take down the first line. F is directly proportional to. Now this is another question which they usually ask in the school. That is, give the mathematical expression for. So this is how you will have to show. Write on this. F is directly proportional to. What is M1 and M2?
Mass.
Mass of the two bodies. Second one,
Yes.
inversely proportional to square of distance. Write that as equation 1, equation 2. Combining one and 2, you will get this. Finally, you write G. What is G? G is a gravitational constant. So I have now F is equal to G M1 M2 upon D square. Suppose I want to find out what is this G. What do? Cross multiply. Correct? So if I cross multiply, I get it as FD square is equal to G M1 M2. Correct? I want to find out G. So what will I do? I will divide both the sides of the equation by M1 and M2. So what will happen? This will get cancelled. So finally, what is G? G is equal to FD square divided by M1 M2. Did you
But
understand?
not without putting M1 and M2, we could just
Correct.
over there.
That is the way we usually say. You shift this M1 and M2 this side, that is it. Basically, what does it mean? No, it's not compulsory, but why are we shifting it down? Did you understand why it was shifted down?
Yes, you can value of G.
Exactly. Okay, we usually in maths what we say with the others, when you take any number on the other side, the numerator becomes the denominator. The plus becomes the minus. Why does it become a minus? Because of the mathematical statement like this. Is that okay? There's no need for you to even show this. But I've shown you why this M1 and M2 have come down. I'll show you this. Okay, all of you have got it in here. Take it down. Okay, so now we have rearranged this equation such that your equation is telling you what the value of what is G. G is your gravitational constant. Let's also try to find out what is the SI unit of G. Okay, so let us look. What is F?
Force.
Force. What is the unit for force? Newton. Very good. So it's Newton. D is what?
Distance.
Distance. Distance is measured in meters. So I'll write it as meter square. Okay? Divided by M1 and M2 is what?
Mass.
Mass. So how many masses? We have got two masses. So it's kg into kg. So it's kg square. Isn't it? M1 and M2 are showing you the mass. It's kg times kg, so it is kg square. Or you can also write it as nm square and kg inverse square. Is that okay? Take down the SI unit of G. Okay, so it's always very easy to find out what is the SI value of any of the terms. You just sort of rearrange. Is that okay? So all of you complete this page here. Till here we have done the derivation of the formula in your textbooks. Textbook not there. You have your volume at least. Volume is there. You have a volume at least you give it. Then both of you sit down together, at least you can share the volume. You also don't have one. Yeah. Is the volume 2? Yeah. You want to go there? Yeah, go. This with the book. At least you'll have something to refer to. Are you all okay with that? Okay. So I have come in here. If you look at your expression in the textbook, next page, go on to the next page here. SI unit. Did you see that? Did you get it? The SI unit of capital G can be obtained by substituting the units of force, distance and mass, and you will get it as nm square upon kg square. Did you understand that? And we have called it as what? It is a constant. This value of G is always going to be a constant. And it was the scientist who has actually calculated using so many different masses, with so many different distances. And what is the value? It was Henry Cavendish who has actually calculated the value as 6.673 times 10 raised to the power of minus 11 nm square upon kg square. Okay, so that is the value. All of you please write down the value. Therefore, the value of capital G. Don't write small g because for small g there is another one. So it is 6.67 times 10 raised to the power of minus 11 nm square upon kg square. Okay, so this is the accepted value. What does it mean that the force between any two masses, maybe between the earth and the moon, okay, or between any two objects which is present, it will have a constant of this. Is that okay? It is not going to change. It is immaterial of whatever is this mass, whatever it is. Okay? Now, we know that there exists a force of attraction. Is it a repulsion? Is it a repelling force or it is a force of attraction? It is definitely attraction force. It's an attractive force because things are getting attractive. That is an attractive force, underline that. Of course, you people will not underline in that book, but for you to remember, make a note of it in your notebook, both of you, that it is an attractive force. Okay? I'm reading out the one which is in the box. The law is universal in the sense that it is applicable to all the bodies, whether the bodies are big or small, whether they are celestial or even terrestrial. Did you understand the meaning between terrestrial and celestial? What is terrestrial? Terrestrial animal का मतलब क्या है? Animals which are on land. When we say it is celestial, it is there out there in space. So bodies, whether they are in space, whether they are on the earth, obviously this particular value will not change. Is that okay till now? Okay. Next is, there are some pretext questions. One is state the universal law of gravitation which we have already written. Okay. And the next one is write a formula to find the magnitude of the gravitational force between the Earth and the object on the surface of the Earth. Now there are few examples which they have already done it in the textbook. We will do it okay, a little later. Now, what is the importance of gravitation, universal law of gravitation? We have already said that this gravitational law holds good for all the objects, whether it is on the Earth or in the space, irrespective of the masses of the two bodies, irrespective of the distance between the two bodies. Okay? And what does it read? Importance. The universal law of gravitation successfully explains several phenomena which were believed to be unfathomable. First, the force that binds us to the earth. Second, the motion of the moon around the earth. Third, the motion of planets around the sun. And fourth, the tides due to the moon and the sea. Okay, so all these phenomena, whether the motion of the moon around the earth or whether it is the earth which is moving around the sun, the formation of the tides, everything is basically, it is interconnected. It depends upon this gravitational force. Is that okay? Now we come to a very interesting paragraph where we are talking about what is known as a free fall. Have you come across this word? What is free fall? Have you seen in movies or on National Geography or any of those channels? What happens to people when they're jumping out of an aircraft? Before before the parachute comes on. Have you seen? It's free fall. When a body is falling only under the influence of the gravitational force, it is called as free fall. Is that okay? So suppose this is the body and this is the surface of the earth and the body is falling down only because of this gravitational force. This body is experiencing the free fall. Okay? And we have also seen what happens to the speed of this body. Will it decrease when it is coming down? Will it remain the same? It will keep on increasing. Initial velocity is small, but as it comes closer and closer and closer to the surface of the earth, the velocity keeps on increasing. That means to say that it is having acceleration or it is an accelerated motion. Is that okay? Initial velocity is less, final velocity is definitely more. So acceleration will be positive or negative? Positive. Correct? So because this acceleration is due to gravity, isn't it? Obviously it is the gravitational force which is causing this acceleration. So this acceleration we are going to use another word which is small g. Instead of using A, we are using this alphabet small g because this is acceleration due to gravity. Is that okay? Did you understand? So acceleration equal to gravity. So three equations you remember, three kinematic equations. What are they? V is equal to
U plus AT
yes.
equals to U plus half AT square
Very good.
and V square minus Q square equal to S.
Very good. So the first one you say V is equal to U plus AT. So what happens to A? All that we are going to do is becomes GT. You understand? So wherever we are having an A, we can change it into G because when we are talking about acceleration. What is the second equation? For all of you writing the books. Write it topic as free fall. All those three kinematic equations we change. So S is equal to UD plus half. Yes. Instead of AB square, this becomes GB square. And third is square is equal to U square plus 2 into A into S. So this A becomes G once again. Did you see that? This is applicable for any of the free falling bodies. Finish, Umra? Right. So whenever a body is falling down, we know that G is going to be positive if it is going to be falling down, but it is having a positive acceleration. Is that okay? But the same body, suppose I'm having a stone in my hand and I'm throwing it up. What will happen to the stone? Decrease. It will decrease. So if the body is thrown up, obviously the velocity will decrease and G is going to be taken as negative because it is negative acceleration. Ultimately, what happens to the stone? When you're throwing it up, after some time it will come to a stop and again it is going to fall. Isn't it? Correct? You're taking the ball, you're throwing it up, it will go to some height, and as it is going, the speed will keep on decreasing. Why? Because the force is in the opposite direction, dragging it down.
Also, holding up is possible.
What is possible? What if G is negative?
Coming down is center, right?
Coming down is positive.
Moving up is negative.
Coming down. Obviously, no, you see, the speed is increasing, speed is increasing, this positive acceleration. Here it is going to be negative acceleration. Is that okay? Here? Okay. Let's see this paragraph. Free fall. Study free fall. There's some activity here. We have learned that the earth, last paragraph. Read over. No. Below that. We have learned. As you can check.
We have learned that they all attracts objects towards them. This is due to the gravitational force. Whenever objects fall towards the earth underneath force, we say that the objects are at free fall.
These all of you write down. What is free fall? Come on, take up. In your notebook. What is free fall? Whenever objects fall towards the earth under the influence of gravitational force alone, under the influence of this gravitational force alone, we say that the objects are in free fall. Did you understand? And obviously we are assuming that the velocities, hot point, forces, etc. are negligible. Okay. We don't cut. We will be after 1 hour we'll have a break. 15 minutes we'll have a break and then 5-10 minutes we'll have a break.
Is there any change in the velocity of falling objects? While falling, there is no change in the direction of motion of the objects, but due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change in the magnitude of the velocity. Any change in velocity involves acceleration. When an object falls towards the Earth, an acceleration is involved. This acceleration is due to the Earth's gravitational force. Therefore, this acceleration is called the acceleration due to the gravitational force of the Earth or acceleration due to the gravity.
Do you understand why we are writing A? Why we are writing it as G? Because G is your acceleration due to gravity, and it is because of the gravitational force. Okay, objects are falling under, they are in free fall. Continue.
It is denoted by G. The unit of G is the same as that of acceleration, that is meter per second square.
Yes. If you look at any of these equations, how did we express A? A is acceleration. So what was the unit? What was the unit? Suppose I say 2, acceleration is 2. 2 के बाद क्या लिखते हैं? Meter per second square. So the same thing, we will write G here as 9.8 meters per second square, because that happens to be the acceleration. You understand? So what is the SI unit of acceleration due to gravity? Take it out. SI unit. Did you see now that I am using small g? It's not capital G. Don't get confused. Small g ka acceleration. Big G is what? Gravitational constant. Use the word constant. SI unit will be meters per second square. Okay. Let's also see another very interesting second law. What is the force? Second law is also known as a force equation, correct? What did it say? F is equal to mass into acceleration, isn't it? And now what are we learning? We are talking about the motion of the bodies because of the gravitational force. Now we also have got gravitational force, which is equal to G m1 m2 divided by d square. Correct? Where did we get it from? This is your gravitational, universal gravitational law. This is also force, this is also force. So we can equate both of them. Isn't it? So we can equate 1 and 2. So when you are equating it, we get it as MA is equal to G M1 M2 divided by D square. Is that okay? Don't write down anything right now. Just listen and then I'll ask you to write. Is that okay till now? Okay. Now what are these M1 and M2? M1 and M2. Instead of writing M1 and M2, I can write mass of the earth and the mass of the object. Isn't it? Because the mass of the earth is huge. So instead of writing as M1 and M2, I can also write here as mass of the earth and mass of the object. Is that okay now? Till now it is okay. Now what has A become? G. It has now become G. Isn't it? A has become G because obviously we know that this is acceleration due to gravity. So if I want to find out acceleration due to gravity, what will I do? I will get this L on the other side of the equation becomes divided by, correct? So I have got G M M divided by D square. ये हमने ऐसे ही copy किया. This M is going to come down. Isn't it? So F comes down and therefore it is getting cancelled out. Now I want to show you why it is coming down. See this, I've got N G G M N by D square. Correct? Why should it come down? Because I want to cascade only for G. So I'm going to divide both the side by N. So that's why it is getting cancelled out. Did you understand why it is getting cancelled out? Because the N has come here, therefore N is getting cancelled out. G is equal to Gm by D square. So this is getting cancelled. So finally, what do you notice? Acceleration of due to gravity depends. This is of course a constant. Depends on what is this capital M. What did we say this capital M was? Mass of what?
Earth.
This is the Earth. It depends upon the mass of the Earth and also the distance between the body and the Earth. That's all. Does it depend upon the mass of the object? Small m is here anyway? No, because it has got cancelled out. So acceleration due to gravity does not depend upon the mass of the object. Are we very clear about it? It's right up. Come on, it. Okay, write down now. First line, according to second law of motion, F is equal to mass into acceleration. F is equal to m into a. Just below this, you would also write it as m into g because now this is acceleration due to gravity. So we have seen why it is getting changed over to small g. Okay, next line you write down this. According to universal law of gravitation. Write down the second line. Okay. Then you write down equating 1 and 2 because this is also F, this is also F, so you can equate these two. Then you write down this sentence. Finally, you are going to find out the value of G. Therefore, small g, which is acceleration due to gravity, is gm divided by d square. Capital M is what? It is the mass of the earth. And d, of course, we know is the distance. Okay? Now, all of you look once again. This is just a diagram for us to tell that the mass of the earth is so huge. If mass is so huge, obviously this is going to be radius, isn't it? And this radius we can also show it as capital R. So to whatever extent that we have taken this body on the surface of the earth, that is going to be negligible as when compared to this R. Is that okay? So this distance between this mass and the earth, for all practical purposes, you can consider it to be only the radius of the earth. Okay? So the same equation, instead of writing it as d square, you can also write it as g is equal to gm divided by r square, where capital R is Take down the last line. Okay. For all practical purposes, we say that the earth is roughly a sphere. But because of the rotation of the earth, this earth is not a perfect sphere. It's more slightly flattened at the poles. And if you're considering this as an equator, it shows that there's a slight bulge. You see that? It's called as a geoid shape. So when we are talking about r, which is the radius of the earth, will the radius of the earth be the same throughout? What do you feel? If you consider this as a center of the earth and this radius here and this radius here, will it be the same? Is it longer somewhere? Yes. Along the equator, along this equator, obviously r is more. And if you're considering r from the center of the earth to the pole, it is obviously going to be shorter. So what happens to the value of g here? We say that g is equal to gm by r square. If r is small, what will happen to g? Inversely proportional, no? So what happens here? If r is small, g will become more. That means to say any body which is dropped at the pole, you will find that g is more here. Okay? And value of g will be less towards the equator. Is that okay? Take down. The value of, now the question is, next question. What is the value of g at the pole and equator? I'll take it in your next page. The question is, what is the value of g, small g, at the pole and at the equator? Okay. First point I know, the earth is not a perfect sphere. Second point, where is it flat?
Poles.
At the poles. It is slightly flattened at the poles. It's like an orange. Orange देखा है? ऐसे ऊपर से flat है ना? Second point, it's slightly flattened at the poles. And where is it bulging? See the diagram. Along the equator. And slightly bulging around the equator.
We don't know the fact.
This one also. Become very stuffy now. I'll switch on the last fan. Third point. क्या बोला? Second point क्या लिखा?
Slightly flattened at poles.
And bulging at the equators. Third point you will write. Therefore, Now I'm going to give it in the form of a fill in the blank. You fill it up. Therefore, the value of G at the pole becomes dash. What will you write? More or less? Yes. G. G becomes more. Value of G at the pole becomes more. And the value of G becomes less at the equator. Is that okay? Clear till now? So just take down this diagram. It's not given in your textbook, but only for you to understand. Okay. Draw that it is flattened there and it's slightly bunched. Okay. So for all practical purposes, that means we have to take an average of these two. Right? Value of at the poles is 9.8, 9.832. And at equator, the value is 9.78. Okay, so this is the value. Okay. If you add up these two and take an average, the average will be about 9.8. Okay, so for all our calculations, we are going to use the average G, which is 9.8 meters per second square. Is that okay? Now we'll do an example sum which is given in your textbook. I'm sure it is there. We'll use one of these equations, right? Did you understand? Everything till now? Any doubt? Clear? Clear? Okay, fine. See that example sum. You have one car falling off or something like that. First example sum.
What's off the level?
Yes, yes. Let's do that. A car falls off a bench and drops to the ground in 0.5 seconds. Let us see what is given to us.
So initial velocity is
Time, is that a time? 0.5 second is given. So they're telling you how much time it has taken to fall down. Correct? Then, and drops to the ground in 0.5 seconds. Then G be 10.8. They have given you the value of G. What is G? Acceleration due to gravity. Correct? Value they have already given as 10 meters per second square. 9.8 is approximately taken as 10. Okay. Many times in the calculations that we will do, they will give you, take it as 10 because it becomes easy to calculate. Suppose they don't give you, then you have to take it as 9.8. Will you remember? Now here they have given, for simplifying the calculations they are asking you to take. What is the speed on striking the ground? Look at this. Here, all of you look here. ये हो गया हमारा car. What is happening to the car? Car is falling down the, correct? So initially will it have a velocity? But when it is striking, definitely. So initial velocity will be 0. Final velocity is what they are asking you to find out. Which equation will you use? Can we do the first one? V is what we want to find out. Initial velocity, we know it does not have 0. Value of G is what? 10. Okay. Time is given to us. Correct? Come on, do it. Required to find. First question is, what is the speed? Come on, find out that. What is the speed on striking the ground? First question.
Final velocity is
Yes.
5.
Now, how will you recognize that it is the final velocity that they are talking? They have not mentioned velocity anywhere. Pay attention here. Speed. When they are saying speed, it obviously tells that it is the velocity. And if this is the car which is about to fall down, initial velocity is 0 here. They're asking you what is happening after it falls down. So use the first one. V is equal to U plus GT. Substitute the values. What are the values here? Initial velocity, U is equal to 0. You have to find T. हो गया?
And the next question is the second.
Let us see. Next question. What is the average speed during the 0.5 seconds? Okay. So the next part of it is, take down the question. To find average speed whenever we have to find out average, initial, final, add it up, and then take the upon 2. Okay, so what is average speed? Initial velocity, final velocity divided by 2. Finished? What is your unit? Right. Speed is nothing but unit will be the same as velocity. Next. What is the next question? How high is the ledge from the ground? Did you understand the ledge and the ground? See this is the ledge and that is the ground. So what are they asking you? Distance. Did you understand? So which formula shall we use then? You can use the second one. Correct. Use the second one. Will it be 2.5? Check it out. U is 0. The first part of half. And so half G. G is 10.
So 2 and then 40 square.
T square. 0.5 into 0.5. Okay, let us see here. We have to find out S. U is 0. Okay. So this entire thing will become 0 plus half G is 10. T, they have already given us 0.5 and there's a square, so 0.5. This will become 5. 5 5s are 25, but there are 2 points, so that becomes 0.25 times 5. That is equal to 1.25. And what will be the unit? Meter. Do all of you do, please do it in your notebook and show me the answer. I want to see the calculation. Go for a small break and come back. Use the washroom. Okay, we continue. I'll show you something that's very interesting. I'll ask you to upload it.
After break.
Yeah, take a break.
Okay. Down and down.
कोई 24 नहीं है मेरे पास 16 नहीं होगा